The second goal on this particular day is to deal with our 6 trig functions. And those 6 trig functions seem to be the Achilles heel of a lot of people in calculus. So we're going to work our way through them, and we're going to try to find a way to make them sustainable, something that we can hold on to without trying to memorize them. So first one, we've already done the top 2, integral of sine, or antiderivative of sine, antiderivative of cosine. Whose derivative is sine of u? Well, let's see. It's going to have something to do with the cosine of u. Actually, we should make this a little bigger so it's easier to see. It's going to have something to do with the cosine of u. Let's see. If I take the derivative of cosine, that's supposed to be the opposite of sine. So that must mean I'd better throw an opposite on there. So opposite of cosine of u plus c. So this antiderivative of sine. Antiderivative of cosine, well, I know it's going to have something to do with the sine of u. I know it's got to have a c in it. Let's see. So if I take the derivative of sine, that's going to give me a cosine. That's going to be exactly what I want. So the top 2 we already know. Those are not big issues. Tangent and cotangent. Let's do a little scratch work here. Integral of tangent. Well, let's rewrite that. That would be the sine of u over the cosine of u. And if somebody said to the antiderivative of that one, I would probably say, well, you know what? If I made u equal to cosine, and then du would have to be sine. So what I would really have in the problem would be the antiderivative of 1 over u du, and I would have, let's see, sorry, if I took the derivative of cosine, I'd get negative sine. So I need to throw a negative in. Well, if I took that antiderivative of 1 over u, I'd be looking at the opposite of natural log absolute value of u plus my c. Well, when I put my u back in, my antiderivative of tangent is going to be the opposite of the natural log of u, which in this case would be cosine plus my c. Forgive me for using u's all over the place, but I did a u substitution, and in doing so, I made u the denominator. That denominator was cosine. I had to throw in the negative because the derivative of cosine is the opposite of sine. So there's derivative of tangent, or sorry, antiderivative of tangent. Antiderivative of cotangent, if I set up basically the same thing, this one would be the antiderivative of cosine of u over sine of u. So now I would make my u, if I was doing a u substitution, and I'm going to ignore the u on the end of that thing. So if I made u sine, then du would be cosine. I wouldn't need to throw anything extra in there. I'd end up integrating 1 over u du, which would be natural log of u, absolute value, plus my c. So now my integral of cotangent would be natural log absolute value of that denominator, which is sine of u plus my c. So what you have, the top 2, antiderivative of sine, antiderivative of cosine, those are ones that we already know. We've already been doing those. Those 2 are probably ones you've already got internalized, or I hope you do. Integral of tangent and cotangent, those are ones that you can figure out without a whole lot of a need for memorization. The 2 down here on the bottom, antiderivative of secant, antiderivative of cosecant, those are going to be a little bit more trouble. And here's what's going to happen. And now, nobody's going to do this, but if you wanted to figure out where this came from, you could rewrite this thing as the integral of secant of u, which was given in the problem, and we could multiply that thing by something that would make a new integral. And here's what that is. Secant of u plus tangent of u on both the numerator and the denominator. Now, I'm not going to think to do that. Well, you're right. You're probably not going to think to do that. So here's why you did it. If we now said u was the denominator, then du would be, derivative of secant would be secant times tangent. Derivative of tangent would be secant squared. If we looked at this, what do I have in the problem? Well, if you distribute the secant on the top, there's your secant squared. There's your secant tangent. If you now go, all right, well, now what do I end up integrating? I really end up integrating 1 over u du. So what do I really have here? The antiderivative of secant is the natural log of the absolute value of that denominator, secant of u plus tangent. Let's write this a little bigger. Secant of u plus tangent of u plus my c. Now we could go through a similar proof over cosecant, but I don't think we're going to do that. I think what I'll do is I'll just give you this last one. The antiderivative of cosecant is the opposite of natural log, absolute value, cosecant of u plus cotangent of u plus my c. So there's your 6 trig antiderivatives. The top 2 you should already have. The middle 2 you can figure out. The bottom 2, the best advice I have for you is you might want to just memorize those. And if you're looking for a pattern, secants always go with tangents. Cosecants always go with cotangents as we're trying to work our way through. So let's try using this once. So here we are, problem number 3. Integral 0 to pi over 4, square root of 1 plus tangent squared. 1 plus tangent squared inside that square root. None of those are going to show up. I wish it was as simple as it's one of these 6, but it's not any one of those 6. So we're going to have to play around with this thing a little bit. Now I know that there is an identity somewhere along the line that says secant squared of x is the same thing as 1 plus tangent squared of x. That's what I do recognize in this problem. So when I rewrite this thing, I've got the integral from 0 to pi over 4 of the square root of, let's see, this secant squared of x dx. Well, that really means I'm really just integrating from 0 to pi over 4 secant of x dx. Well, we just got done doing this. It's right above here. So the antiderivative of secant is natural log. So let's see. So I've got natural log, absolute value, secant of x plus tangent of x. And we're going to evaluate that going from 0 to pi over 4. All right, so if I go to do that, so that means I have natural log of absolute value, secant pi over 4 plus tangent pi over 4 minus natural log absolute value, secant of 0 plus tangent of 0. Well, let's see, pi over 4, that's 45 degrees. So cosine of pi over 4 would be 1 over root 2, so secant would be root 2, plus tangent would be 1, minus natural log, secant of 0 would be the same as cosine of 0, which is 1, tangent of 0 is 0. What I really have is I have natural log of the quantity root 2 plus 1, minus natural log of 1. Natural log of 1 is a big fat 0. So when I figure all of this out, what I really have is I have natural log quantity root 2 plus 1. And I think I don't have to worry about subtracting anything at all. There's my solution. So those trig antiderivatives, this second goal of this day, we only did one problem with it, but we figured out how we can do all of them. This is a big tripping point for a lot of students in calculus.